Hello everyone, I am Dr. Gangadhar Mishra and we are continuing our lecture series in VLSI and embedded system. Today we are going to cover our topic NMOS fabrication. So the course outline is as follows. We will start the fabrication process and during our discussion on fabrication process we will look around what is photolithography, etching and carrier diffusion. So step by step we will process and see how the ICs are being fabricated on a semiconductor chip. So before going to the topic, we must come through the semiconductor and its devices. So this is the basic structure of an NMOS transistor which we have seen earlier. So in this NMOS enhancement type semiconductor material or transistor, we will see that a p-type substrate carries the source and drain regions which are n plus regions, and the gate region is just laid over this semiconductor material, and a semiconductor silicon dioxide layer is placed between the gate and the substrate. So accordingly we will process the design step by step to achieve all these incorporations in a semiconductor chip. So to begin with the process, we will first select what type of semiconductor material we need to take as a base material or the substrate. So in order to fabricate a NMOS transistor, we need to take a p-type silicon as substrate, and on the contrary, if we are going to fabricate a PMOS, we need to take a n-type semiconductor material. So the first step starts with the fabrication of a silicon dioxide layer on top of this substrate. So to form a silicon dioxide layer on this p-type silicon substrate, we follow the oxidation process. In this oxidation process, the substrate is heated at around 2100 degrees centigrade in the presence of oxygen, and for a substrate thickness of around 700 micrometer, the silicon dioxide layer created here is around 1 micrometer. So we can calculate how much is the requirement and how much we should develop this layer so that our functionality can be achieved. So once this silicon dioxide layer is created on this substrate, next our process is the photolithography. So what is this photolithography process? This photolithography process is the process in which the different regions are enmarked and created so that the diffusion process and the gate implantation can be carried out. So to begin with the process, we start with the application of the photoresist. And what is a photoresist? It is a resin material which is reacting to the ultraviolet light. So photoresist are of two types. One is positive photoresist, one is negative photoresist. So in case of a positive photoresist, it can be dissolved with sulfuric or hydrofluoric acids. And negative photoresist property is that when it is exposed to the UV light, it is hardened and it is not soluble with these acids. So depending on our requirement, we can use suitably the type of photoresist for our particular application. And mostly in industries, the positive photoresist are used because it gives a sharp cutoff. So once the photoresist is applied, then a mask is placed over this photoresist which indicates which area is to be removed and which area is to be kept intact. Accordingly, that mask will be protecting those areas which are not to be disturbed during this fabrication process. And finally, the UV light is applied and that light will be interacting with this photoresist layer which are opened in the mask, and rest areas are unexposed. Accordingly, on application of the HF acid or sulfuric acid, we can clear those areas, and by the etching process we can remove the silicon dioxide which were applied or created earlier on the top of the substrate, so that my transistor fabrication area is open for my further processing. And the next step in this process is to create the gate and the source and drain regions. To create the gate region, we can see first a thin layer of silicon dioxide is created. Thereafter, this polysilicon gate is applied, and on insulating that gate region, we have diffused the N plus regions as source and drain. So these N plus regions are created by doping the pentavalent impurities in that particular area, and we can also see in this slide that the N plus regions created for source and drain are identical. So we can use interchangeably those source and drain terminals. So the next step is to take out the terminals which can be used for further connection into the circuit. So these terminals are connected by the process of metallization, which connects the source, drain and gate to the external world. And finally, we need to cover all the surface through the silicon dioxide, which is a insulating medium, so that my IC is protected, my transistor is protected, and it will not be accessible by anyone else, and only the terminals are coming out, and we will be using those terminals for further connectivity. So finally, we summarize all these steps in the following video.
A new silicon layer is applied over the oxide layer. And once again, a layer of lacquer is applied, exposed, and developed. The silicon which is uncovered by this process is then etched away. Another series of treatments involving lacquering, exposure, bombardment with atoms which penetrate the silicon, new oxide layers, etc. is performed until the whole pattern is complete in all its layers. Some 300 to 400 process steps are required, along with 15 to 20 different masks with microscopically small patterns. The final step in the process is the connection of the various, almost invisible, tiny elements in the silicon.
So we have seen the different steps of the fabrication of a NMOS transistor, and further, if anybody can be thoroughly be reviewed in this reference link which I have shown here, and you can note it down so that you can go through this link and watch this complete lecture in the online mode. Thank you all.